A recent retiree requires $5,000 per year in extra income. She has $60,000 to invest and can invest in B-rated bonds paying 13% per year or in a certificate of deposit paying 3% per year. How much money should be invested in each account to realize exactly $5,000 in interest per year? When we're looking at earned interest from two different accounts, we can use a 3x3 table to organize the given information and to help us come up with the equation that we're supposed to solve. The first row is going to be where we put info about the B-rated bonds, and the second row is going to be where we put info regarding the certificates of deposit. And this third row is going to relate to the financial goal that we're trying to achieve. Before we talk about the column headers, let's make note of the fact that we're looking at the amount of interest that accumulates in 1 year. So when we plug in time is equal to 1 using the simple interest formula, we get that the simple interest can be calculated by looking at just the initial principal multiplied by the rate. We want our columns to be labeled with headers such that we're multiplying the first two columns together and the product is going to be written in the third column, and that means that we want our column headers to be initial principal multiplied by rate, and the output over here in the third column will be the corresponding interest that's earned from each of these accounts. This is a template that can be memorized and used for any problem where we are combining interest from two different accounts. Now it's time to populate the cells. When we go back and reread the problem, we see that the retiree's goal is that they earn $5,000 per year in extra income. When we're given the financial goal, that's going to populate this bottom right cell. We want to earn $5,000 in interest, and if we don't have to calculate that financial goal, then we don't need these two cells here. We know that the B-rated bonds are paying 13% per year, so we'll convert that percentage to a decimal and put it in the rate cell for the bonds row. And the CDs are paying 3% per year, so again, we'll convert it to a decimal and put that in our CD row. Now it's time to figure out what we're going to put in the principal cells. But those are our unknown quantities. How much should be invested in each account? This is where we want to identify the unknown quantities specifically. One of the values that we're asked to find is the amount of money in the bonds account. The other is the amount of money in the CDs. When we have two unknown quantities, one of them is going to get an X. And in this situation, it really doesn't matter which one. Because we started off with $60,000 initially and we put X of those dollars into the bonds account, that means what remains to go in the CDs account is the $60,000 that we started with minus the X number of dollars that we put in the bonds account. Now we have two variable expressions that represent our unknown quantities, and both of them are in terms of X, which means we'll be able to create a linear equation in one variable. So we'll put these quantities in our table. The amount of principal going into the bonds account, we let that be X, and the amount of principal going into the CDs account, we said that was $60,000 minus X. Once we have the first two columns populated, we want to multiply these two together in order to populate the third column. When we multiply across, we get the interest from each account. For the bonds account, we get 13% of, which means multiply, however much money is in there, and we said that quantity was X. To get the interest from the CD accounts, we have 3% of means multiply. The amount of money in that account is $60,000 minus X. So when we multiply across, we get the interest from each of those accounts. To create the linear equation that we're going to solve, we'll add down, adding the two interest values to come up with the total interest that was our financial goal. So the equation is the amount of interest earned from the bonds account, which was 13% of however much money was in there, plus the amount of interest that we earned from the CDs, which was 3% of the amount of money in that account, is going to be equal to the total of $5,000, which was our financial goal. And now what we have is a linear equation in one variable. So in order to solve for X, we'll simplify the left-hand side as much as possible, beginning with distributing in the 0.03. 0.03 times 60,000 is 1,800. 0.03 times negative X is negative 0.03X. This is still equal to 5,000 on the right-hand side. Now we'll combine like terms. 0.13X minus 0.03X is 0.10x, and let's just call that 0.1x. We still have plus 1,800, and we're still equal to 5,000. So now let's subtract 1,800 from both sides. 5,000 minus 1,800 is 3,200. And when we divide both sides by 0.1, they cancel out on the left, leaving just x. And on the right-hand side, we have 3,200 divided by 0.1, which is 32,000. So x is equal to $32,000, and that's what we had put into our bonds account. So now let's just clearly state our answer, and then the amount of money in the CDs account is going to be $60,000 minus the $32,000 that is the x quantity, which leaves us $28,000. And so these are the amounts that go in these designated accounts.